Hello students, how are you? Welcome to my channel, the logical domain of DJ, where you can learn mathematics more logically and more technically. So in our today's video, we will do some problems on compound angle. You know, this is a very important chapter in trigonometry. So today's video will be very much crucial and very important for students who are going to learn trigonometry for the first time. So before we start, if you are first time in my channel, then subscribe the channel and press the bell icon to get the video notification on your mobile. So let's start with a very common and very important problem of compound angle. Number 1, we have a problem tan 35 plus tan 10 degree plus tan 35 tan 10 degree equal to 1. We have to prove this trigonometric identity. In MCQ pattern, we have to question find the value of this trigonometric expression. Otherwise, it can be write in this way: prove this trigonometric expression, its value is 1. Now, how can we approach to the problem? First of all, we have to see whether what are the angles are there. These angles are 35, 10, 35 and 10. So there are two angles, 35 and 10. Now see, if you add this 35 plus 10, you get 45. Which one is a standard angle? So we will start using this 45 degree angle. That is 35 degree plus 10 degree equal to 45 degree. Now we will take tan in the both side. That is tan 35 degree plus 10 degree equal to tan 45 degree. That is our main crucial part of this problem. Then we will break the left hand side. We know the formula tan a plus b. What is tan a plus b? That is our formula, tan a plus b equal to tan a plus tan b 1 minus tan a tan b. So we will apply this formula in the left hand side. Then what we will get here? Tan 45 tan 10 1 minus tan 35 tan 10, and what is the value of right hand side? This one equal to 1. So cross multiply them. That is tan 35 tan 10 degree equal to 1 minus tan 35 tan 10 degree. So you can easily understand we have got our required result if you take this term to the left hand side. Then you have got your required result, that is tan 35 tan 10 plus tan 35 tan 10 equal to 1. So that is our proof. So we approach to the problem with a standard angle from the observation that sum of these given angles are 45 degree. So this is our first problem. Now we will do similar types of problem. Number 2 is this type of problem. What is the problem? Number 2. Number 2, you have to prove tan 70 degree equal to 2 tan 50 plus tan 20. We have to prove this expression, that is tan 50 equal to tan 70 equal to 2 tan 50 plus tan 20 degree. Now how can we approach to this problem? See, here are three angles, 70 degree, 50 degree and 20 degree. And what you see here, 50 degree plus 20 degree equal to 70 degree. So we will approach in this way, that is 50 degree plus 20 degree equal to 70 degree, and we apply tan both sides, that is tan 50 plus 20 equal to tan 70 degree. Then you break the left hand side, tan 50 tan 20 by tan 50 tan 20 equal to this one tan 70. We don't, this is not a standard angle, so we multiply, cross multiply them. Then what's happened, left hand side is tan 50 tan 20 equal to tan 70 minus tan 70 tan 50 tan 20 up to this line. Now what's happened, tan 20 we have got tan 50, but here 2 tan 50, but we have got 1 tan 50. Tan 70 on the another side, tan 17 also clear. Now our problem with this problem, this term and this term, with we require another tan 50. Now see how can we get from this term tan 50. You see 70 degree plus 20 degree equal to 90 degree. So they are complementary angle. So we can change the angle. Then what will happen, tan 50 tan 20 equal to tan 70. If you change this angle, tan 70 means cot 20 degree. This one complementary angle, 70 plus 20 equal to 90. So we can change tan into cot. This one tan 50 and tan 20, and tan 20 cot 20 will be cancelled. So this one only tan 50, and if we transfer this tan 50, shift this tan 50 to the left hand side, we have got 2 tan 50, and that will be our required result. If you shift this tan 50 to the left hand side, you have got 2 tan 50 plus tan 20 equal to tan 70. So clear to everyone how can we approach to the problem? Just observing the angle, what are the angles given in the problem, is there any relation with the angles, is the sum of the two angles is another angle, then we will apply the formula of tan, simple calculation, and you will get our required result. Next, our third problem. Number 3. What is the problem? Here is given a plus b equal to 45 degree. Then we have to prove if, then prove that 1 plus tan a into 1 plus tan b equal to 2. We have to prove this identity when the relation between the angles is, the sum of the angles is 45 degree. Now how can we approach to the problem? There are so many ways to approach to the problem. I give very simple technique. Suppose this one 1 plus tan a, and I change the angle b. 1 plus tan, what is b? B means 45 degree minus a. So I replace here this one 45 degree minus a. I just replace the angle b with 45 degree minus a. Now this one is your tan a minus b formula, so I can break. So this one plus tan a. If you break this tan 45 degree minus tan a, tan 45 degree tan. Clear to everyone? Now what is the value of tan 45? Tan 45 means 1. That is, this term will be 1. Also this term will be 1. So actually it becomes 1 plus 1 minus tan, 1 plus tan. Now we add 1 plus tan a. If you add this one, 1 plus tan a, 1 minus tan a, denominator is 1 plus tan a. You see, you have got your required result, because 1 plus tan a cancelled, tan a cancelled, and you have got your required answer 2. So this is a very simple process. Just replace this angle by 45 degree minus a, then break the tan, just add them, and you have got your result. Here another question also given. What is this one? Also find the value of tan 20 and half degree. In the same question, how can we calculate tan 22 and half degree using this relation? Now, when a plus b equal to 45 degree, we have already proved 1 plus tan a into 1 plus tan b equal to 2. This is an identity, and this is valid for any value of a and b such that their sum is 45 degree. For any, you can take 30 plus 15, this one 45 degree. You can take a 20 degree and b is 25 degree. Any value of a and b. Now here we will use if a and b are equal. If a equal to b, then a equal to b equal to 22 and half degree. That is, see, 22 and half is the half of the 45. 22 plus and half is the half of 45 degree. So we will apply this relation when a equal to b. That is, when a equal to b, this relation becomes 1 plus tan a its whole square equal to 2. Then what you will get? 1 plus tan a equal to plus minus root 2. That is, tan a equal to plus minus root 2 minus 1. When a equal to b, then a means 22 and half degree. A equal to 22 and half degree, and which is an acute angle. Now you know, for any trigonometric ratio, if a is acute angle, then its value is positive, because this angle lies in first quadrant. So this value cannot be negative. So tan 20 and half degree, we can take the negative sign. We will take plus 2 minus 1. That is our required answer. That is, the value of tan 22 and half degree is root 2 minus 1. We can take the negative value because this is an acute angle and this angle lies in first quadrant. Any trigonometric ratio have positive value in first quadrant. So that is very common problem, very frequently given in various types of examination. So this is very simple proof. Now we will go to the fourth problem. What is the problem? Here given A plus B plus C equal to phi. Phi means 180 degree. It is sum of three angles of a triangle. A plus B plus C are the angles of a triangle. Their sum is 180 degree, that is phi. Then we have to prove two identity. The first proof is prove that tan A equal to tan B plus tan C. Our second proof is 2 cot B cot C equal to 1. We have to prove these two relation or these two identities when A plus B plus C is pi. Now see how can we approach to the problem. For the first one, tan A. What is tan A? Tan A means sin A by, another condition is also given, and another condition is cos A equal to cos B plus cos C. This condition also given. Two conditions. One is with the angles ABC, another is cos A equal to cos B cos C. These two conditions are given and we have to prove these two identities, tan A equal to tan B plus tan C and 2 cot B cot C equal to 1. Now for the first one, tan A equal to sin A by cos A. Now our target is to convert this angle into B and C because the right hand side is in the term B and C. So we change this angle. What is A? A means pi minus B plus C. And what is cos A? Cos A means cos B cos C. Clear to everyone? Now what is this one? Pi minus theta. Pi minus theta means in which quadrant? Pi means 180 minus in second quadrant, and in second quadrant sin is positive, and as pi is the even multiple of 90, so sin will be sin, that is this one will be sin B plus C by cos B cos C. Clear to everyone? Now I will break this sin B plus C. If you break sin B plus C, what is sin B plus C? Sin B cos C cos B sin C by cos B cos C. Now you can easily understand, if we separate them, sin B cos C by cos B cos C, this cos C will be cancelled, sin B by cos B equal to tan B, and if this by this, cos B cancelled, sin C by cos C, that is tan C. That is our required result. So clear to everyone? So see how we just approach to the problem from A to B and C. We break them sin cos and then change the angle into B and C. Then simple just using the formula of compound angle, you can get the required result. Now what is the second one? What will be the second one? The second identity, we have to prove 2 cot B cot C equal to 1. Now for calculation, I start in this way, 2 cot B cot C minus 1. I will show the value will be this one equal to 0. If I can prove the value of this expression is 0, then 2 cot B cot C equal to 1. Now see what happened. I break them in sin cos, that is cos B cos C by sin B sin C minus 1. Subtract them, 2 cos B cos C minus sin B sin C by sin B sin C. Now see, this may be a formula cos B cos C sin B sin C, but there is a 2, that is our problem. Now I can write this 2 cos B cos C as cos B cos C plus cos B cos C. I just write in this way, cos B cos C plus cos B cos C minus sin B sin C by sin B sin C. Then see, this is an formula cos A cos B minus sin A sin B, that is cos A plus B. This one becomes cos B cos C plus cos B plus C by sin B sin C. Now what is B plus C? B plus C means pi minus A. I erase them. This cos B cos C means cos A, and replace this angle at pi minus A. Now what is pi minus A? Pi minus A, this one also in second quadrant, and in second quadrant cos is negative. So its sign will be minus, as this one is even multiple of pi by 2. So cos will remain cos by sin B sin C. This one is 0. So we start from here. We have start from here 2 cot B cot C minus 1 equal to 0. We have proved this one. So 2 cot B cot C equal to 1. This is a very technical proof. Clear to everyone? See what the calculation. Given conditions are this one, and we have to prove these two identities. If there is any problem, you can write in the comment box. If there is any doubt or any confusion in this technique, then I will reply them in the comment. Now I will forward to the fifth problem. This one also very interesting problem, number 5. We have given cos theta plus sin theta equal to root 2. Then find the value of, what is the value of cos 3 theta? If cos theta plus sin theta equal to root 2, then you have to find the value of cos 3 theta. How can we calculate the angle from this type of relation? This relation is a special type of relation. This relation is linear combination of sin theta cos theta. Linear combination of sin cos. That is, power of sin cos is 1. There is no multiply between sin cos. This type of expression we can easily convert them into only sin or only cos. See how can we approach to the problem. So I just shift this root 2 to the left hand side. Then what will happen? This one is 1 by root 2 cos theta, 1 by root 2 sin theta equal to 1. That is, I have shifted this root 2 to the left hand side. Now I can easily convert this expression into cos structure or into sin structure. If we want to convert them cos structure is cos A cos B plus sin A sin B. That is, we have to write this value in terms of cos, we have to write this value in terms of sin. What is 1 by root 2? 1 by root 2 means cos 5 by 4. This one in terms of sin, 1 by root 2 means sin pi by 4 means 1. You see, you have got a formula of cos A cos B plus sin A sin B. If anyone want to convert this expression into sine, then you can write here sin 45, this one is cos 45. Then it will become sin A cos B plus cos A sin B. This is sine formula, but I convert them in cos structure. So what is this one? This one is cos theta minus pi by 4 equal to 1. Now 1 means cos 0 degree. That is theta minus pi by 4 equal to 0. That is you have get theta equal to pi by 4. Now we can easily calculate the value of cos theta as we have got the value of theta. Therefore, cos 3 theta equal to 3 into pi by 4. I can easily write them in this way, pi minus pi by 4. This one is 3 pi by 4. So you can write 3 pi by 4 in this way, pi minus pi by 4. And this one is in second quadrant, and in second quadrant cos is negative. And this one is cos pi by 4. So this one becomes minus 1 by root 2. Clear to everyone? Is there anything confusion? We have shift this root 2 to the left hand side, convert the structure into a formula of cos A cos B, sin A sin B. Then this one cos A minus B, that is theta minus pi by 4 equal to 1. 1 means cos 0 degree. So you have got theta minus pi by 4 means 0, theta equal to pi by 4. And then you can calculate the value. This one is minus 1 by root 2. Now we will go to the problem number 6. What is the problem? Number 6, another type of problem. Cos square pi by 4 plus theta minus sin square pi by 4 minus theta. We have to find the value of this expression. Now this one is a formula. Cos square A minus sin square B. What is the formula? This one is cos A plus B into cos A minus B. So we can apply this formula to the problem. This one is our A and this one is our B. So this one becomes cos A plus B, that is into cos A minus B, pi by 4 plus theta minus pi by 4 plus theta. Now we can easily calculate this one, minus theta, pi by 4 minus pi by 4. You have got cos pi by 2, cos 2 theta. Now cos pi by 2 is 0, cos 90, result is 0, so result is 0. Very simple question if you know the formula of cos square A minus sin square B. Similar types of problem. Number 7. Sin square pi by 8 plus theta by 2 minus sin square pi by 8 minus theta by 2. This one is your another formula, sin square a minus sin square b equal to sin a plus b into sin a minus b. So we will apply this formula here. This one is your angle A, this one is your angle B. So we just apply this formula, sin A plus B into sin A minus B. So you can easily calculate them. This one cancel. Here theta by 2 minus theta by 2 cancelled. This one is sin pi by 4 and this one is sin theta. What is sin pi by 4? 1 by root 2. 1 by root 2 sin theta. That is your answer. So these types of formula, these types of problems you can easily calculate from the formula. That's why in the previous video we have told you that you have to memorize for all the formulas of compound angle, then you can apply this rule to various types of problem. Now for the next problem, that one is very important problem, very technical also. What is the problem? Number 8. Number 8. This one very important. Here is a condition, if sin theta equal to k into sin theta plus phi, then prove that tan theta plus phi equal to sin phi by cos phi minus k. That is our problem. Everyone attend to the problem. Sin theta equal to k sin theta plus phi, then we have to prove tan theta plus phi equal to sin phi by cos phi minus k. See in the result, in the right hand side only phi, that is we have to separate this phi from theta. How can we approach to the problem? There are so many ways also, but I will give very extraordinary solution here. I write this theta in this way, theta plus phi minus phi. I can write this theta in this way, that is I write in this way, equal to k sin theta plus phi. I just write this theta in this form, theta plus phi minus phi. If you open the bracket, phi minus phi will be cancelled, so this will simply theta. But for the sake of calculation, I just write this theta in this way. Now I break them, sin a minus b, sin a cos b, cos a sin b equal to k sin theta plus phi. Now I take this sin theta plus phi term to the left hand side, because here also another sin theta plus phi. So I take this term to the left hand side. If I take common sin theta plus phi, then this one will be cos phi minus k, and I shift this term to the right hand side, cos theta plus phi sin phi. Clear to everyone this line? I just shift this term to the left hand side and take common sin theta plus phi, here cos phi, here k, that is minus k, and shift this term to the right hand side. Now our requirement is tan theta plus phi, here sin theta plus phi, here cos theta plus phi. So you divide this term, sin by cos means tan. So I just shift cos this one, cos theta plus phi equal to sin phi by cos phi minus k, and this one is our tan, and that is our required result. Tan theta plus phi equal to sin phi by cos phi minus k. So that is our problem, and we have approached to the problem very technically, and this is the shortest method in this proving. We have to just break this angle in this way, then apply the formula of sine, separate sine and cos, divide by cos, you will get the required result. This one is very technical and tricky also. Now we will go to the next problem 9, which is very much different from all the previous problem. Number 9. What is the problem? Here is an expression 5 cos theta plus 12 sin theta plus 12. We have to calculate the maximum and minimum value of this expression. Maximum and minimum value of the expression. How can we find its maximum and minimum value? This is a trigonometric expression, and this one is linear combination of sine and cos, like our previous question number 5, linear combination of sine and cos. So we can express this expression into only sine or into only cos, and that is our target in this question. We just want to convert this expression into single sine formula or into single cos formula. How can we approach them? We can approach to the problem in this way. If this one is A and if this one is B, we will divide this expression by root over of A square plus B square. This is a very general calculation. If the coefficient of cos theta is A and coefficient of sin theta is B, then we have to divide this expression by root over of A square plus B square. That is, here we will divide this expression by 5 square plus 12 square, that is 13. Now see what will happen. That is, I start in this way, 5 cos theta plus 12 sin theta. I just first calculate this term. I will divide them by 13. 5 13 by 13 cos theta, 12 by 13 sin theta. So I will take a 13 common in this way. So clear to everyone from where we will get this 13? We will get this 13 from the coefficient of sin and cos. Divide them by the root over of A square plus B square. Now if you want to convert this expression into cos term, cos structure, then you have to take this one is cos and you have to take this one is sin. See, this value 5 by 13, this is a proper fraction, so it may be a value of sin theta, may be a value of cos theta, because we know all the values of sin and cos lies between -1 to +1. So say we take cos alpha equal to 5 by 13. Then what is cos alpha? Then what is sin alpha? Sin alpha equal to root over of 1 minus cos square alpha. That is 1 minus cos square alpha means 25 by 169. That is 12 by 13. That is, if you take this one cos alpha, then it will sin alpha. That's our technique. That is, when you divide this term by root over a square plus b square, then you can easily convert them sine or cos structure. If you take this one sine alpha, then this will becomes cos alpha. So then what happens? This problem becomes this one equal to 13 if you replace this one as cos alpha cos theta, sin alpha sin theta, and this one equal to 13 cos of theta minus alpha, cos a minus b formula. Now our first target in this problem, we convert this expression into single cos just. Now what is our relation, or what is our known fact about cos theta minus phi? This angle lies between -1 to +1. This is a very common inequation, that is for any angle of cos, this value always lies between -1 to +1. Now first we multiply with them 13, that is -13 less than equal to 13 cos theta minus alpha less than equal to 13. But our actual expression was this expression plus 12. This one is only this one. So we add 12 in every side, that is -13 plus 12 less than equal to 13 cos theta minus alpha plus 12 less than equal to 13 plus 12. That is -1 less than equal to, this one means this one, 5 cos theta plus 12 sin theta plus 12 less than equal to 25. So from this inequation you can easily say its maximum value is 25 and its minimum value is -1. Max value 25, mean value is -1. So clear to everyone? This is a very different type of problem, and this is very much common in various types of examination. In this way we can easily calculate its maximum and minimum value. Now our last problem in this video, number 10. If cos of beta minus gamma, cos of gamma minus alpha plus cos of alpha minus beta equal to -3/2, then prove that cos alpha plus cos beta plus cos gamma equal to 0, sin alpha sin beta sin gamma equal to 0. Clear to everyone? Cos of beta minus gamma, cos of gamma minus alpha, cos of alpha minus beta equal to -3/2. Then we have to prove sum of cos alpha cos beta cos gamma equal to 0, sin alpha sin beta sin gamma equal to 0. Now see how can we deal this problem. We just break this will be lengthy. So if you break them and take this 2 to the left hand side, so I take 2 to the first, so this one becomes cos beta cos gamma plus 2 sin beta sin gamma. That is for the first term. For the second term, 2 cos gamma cos alpha plus 2 sin gamma sin alpha. This one for the second term. Third term, 2 cos alpha cos beta 2 sin alpha sin beta. Left hand side there are -3. Now how can we write this minus 3? Minus 3 means minus 1, minus 1, minus 1. Now I can write this one as sin square alpha plus cos square alpha, this one as sin square beta plus cos square beta, and this one as sin square gamma plus cos square gamma. So I just write here, this one is minus sin square alpha plus cos square alpha minus sin square beta plus cos square beta minus sin square gamma plus cos square gamma. Clear to everyone? How we have break this expression? These are the cost problem, cost structure, and I take this minus 3 as minus 1, minus 1, minus 1. Now I just shift all the terms to the left hand side. In this way, what will happen, you see, if you take all the cost structure, that is cos square alpha, cos square beta, cos square gamma, and here cos, this cos and this cos. I take all the cost structure in one parenthesis and all the sin structure to another parenthesis. Then see what's happened. I take all the sin, all the cost structure first. So you get here cos square alpha, right from here, cos square alpha, cos square beta, cos square gamma plus all the cost structures. This one or all the cost structures plus, if you take all the sin structure, sin square alpha, sin square beta, sin square gamma, equal to 0. Right hand side is 0. Now what is this one? A square plus b square plus c square 2ab 2bc 2ac. A square plus b square plus c square 2ab 2bc 2ac. That is this one, a plus b plus c whole square. So we have got cos alpha plus cos beta plus cos gamma whole square, sin alpha, sin beta, sin gamma whole square equal to 0. Now see what's happened. This is the sum of two square term is 0, and you know, if sum of two square term is 0, then they are 0. That is, this term will be 0 and this term will be 0, because they are square term. Square term cannot be negative, as their sum is negative, sum is 0, so they must be 0. That is, from this relation we can easily say cos alpha plus cos beta plus cos gamma equal to 0, and sin alpha, sin beta, sin gamma equal to 0. That is our required result. This is a very lengthy structure, but if you understand the technique, it's not very tough. So up to this one, we have done so many tricky compound angle with special technique. You have already seen it. So what is our tendency in this chapter? First of all, we have to remember all the formula of compound angle. In the previous video, we have already discussed all the formula, and then you see all this problem, how do we apply this formula in the calculation or in the proving or in the calculating of the value. So practice all the problems. There are so many other problems also, but there are some important and tricky problems which we can deal with some techniques. So still then, keep learning, take it easy, don't be panic in trigonometry. Trigonometry is very much interesting if you understand them. So still then, keep smile. Thank you. We will take our next video on another trigonometric chapter, that is the transformation of sums and products of the angle. That one is also very much important. So still then, practice all the problems of compound angle. Thank you.